Hello everyone! Welcome back to 60-second stats, statistics in 5 minutes or less. We're going to expand upon our study of quantitative variables and talk about two different kinds of quantitative variables, discrete variables and continuous variables. Let's get started. Before we jump into discrete and continuous variables, it's important for us to review qualitative versus quantitative variables. Discrete and continuous variables are types of quantitative variables, so it's important for us to be able to distinguish what a quantitative variable is. So qualitative or categorical variables represent qualities, attributes, categories, and characteristics, things like shape and color. They're typically not numbers, but if they are numbers, they do not provide meaningful values when operations are performed. Something like the number on a football jersey. If we added or subtracted two numbers on football jerseys, nothing valuable comes out of that. Whereas quantitative variables are numerical values, and if we perform operations on them, they do provide meaningful values. Things like age and household income. So the reason we needed to review quantitative and qualitative is because we're going to sort of zoom in on quantitative variables because there's two different kinds of quantitative variables. So we're gonna just sort of push qualitative variables off to the side for a minute and just zero in on quantitative variables. So there are discrete quantitative variables and continuous quantitative variables. And so a discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. The term countable means the values result from counting such as 0, 1, 2, 3, and so on. A discrete variable cannot take on every possible value between any two possible values. All that means is when we're talking about discrete variables, we're talking about whole numbers, 0, 1, 2, 3, okay? But continuous variables are quantitative variables that have an infinite number of possible values it can take on and be measured at any desired level of accuracy. So for continuous variables, we're talking about real numbers. We might be talking about those whole numbers, but we might also be talking about fractions or decimals. Okay, so we're talking about sort of a measurement. Let's take a closer look at that. Let's take a look at some real examples of discrete and continuous data. Because I find when we put things in context, it makes them a lot more understandable. Remember, discrete data represents countable data. If we can only count using whole numbers, we are talking about discrete data. Whereas continuous data can be broken down even further. We can use countable numbers, but if we can also break it down into fraction or decimal form, then we're talking about continuous data, typically levels of measurement. So let's consider books. The number of books in this bookshelf is 14. That's a countable number, and we can't break it down any further than that. We're not going to say we have 14 and 1/8 books on a bookshelf. That just doesn't make any sense. So that's discrete. Whereas the length of the page of a book would represent continuous data, because if we measured the length of this page, well, it might be 5 inches, but it might also be 5 1/4 inches. So we can break that down into even further into a decimal, making it continuous data. Now let's think about students. There's 6 students in this class. That's a countable number. It's a whole number, and we can't break it down any further because it wouldn't make any sense to say we had 6 1/8 students in a classroom. That's discrete data. Whereas the weight of each student in a class would be continuous data, because while this child might be only 32 pounds even, she might also be 32.32 pounds, meaning we can go beyond countable numbers into a level of measurement of decimals, making this continuous data. Now let's think about the players in a race. Well, here we have 10 racers ready to go. That's a countable number. Can we break it down any further than that? No, because it wouldn't make any sense to say we had 10 2/5 racers in a race, making this discrete data. But the time taken by each player to finish the race, well, that's continuous, because while she might finish it in 25 seconds, she might also finish it in 25.34 seconds, meaning we can go beyond countable numbers and into levels of measurement, making this continuous data. Here are some visual definitions for you to take a look at. You never know what's going to help you remember something. I recommend pausing the video and considering discrete and continuous data from all of these different perspectives. It might help you understand better. If you'd like more examples, take a look at this chart, which can really help you break down different qualities of discrete and continuous data. I recommend pausing the video and reading through it. Now it's time for you to practice applying what we've just learned about discrete and continuous variables. Classify each of the following quantitative variables considered in a study on eating habits as discrete or continuous. Remember, when we're talking about discrete and continuous data, we are only talking about quantitative variables, numbers that have meaning when we perform operations. Pause the video now and classify each of these as either discrete or continuous, then unpause to see the answers. Be sure to check out the Kahoot located at this link for some extra practice with discrete and continuous variables. Reach out with questions and have fun!